This video is about graphing the tangent function. And we're going to do that using our unit circle. So here's the unit circle we keep referring back to. Notice we've got here at 0 degrees, we're at a coordinate of 1, 0. At an angle of pi over 4, the coordinate is square root of 2 over 2 in the x-coordinate, and the y-coordinate is then square root of 2 over 2. Now when we graph a tangent, let's look at our equation for tangent, and that's the fact that the tangent of theta is then going to equal y divided by x. So to find our tangent, we're going to take the y-coordinate and divide it by the x-coordinate. Let's go ahead and make a chart, and then we'll use this chart to help us graph it out. We're going to start off with a theta equaling to 0. When theta is equal to 0, then we are looking at this coordinate right here. We are sitting on the x-axis, so that's going to be 0 over 1, which is just 0. When theta is then equal to pi over 4, let's look at these coordinates. Here we got the coordinates of the square root of 2 over 2, square root of 2 over 2. Those are going to cancel for us, so then tangent of theta is just 1. Now life gets a little interesting, because what's going to happen at pi over 2? At pi over 2, we're going to have 1 over 0. And as you know, in the land of math, we never have 1 over 0. So our tangent of theta at pi over 2 is undefined. If we move over to 3 pi over 4 as we're moving around the unit circle, now what's going to happen? We're going to have a negative square root of 2 over 2 divided by a positive square root of 2 over 2. That's all going to cancel. I'm going to have a negative up there, so I'll end up then with a negative 1. At pi, once again, we're looking at our y over x value, so it's going to be 0 over a negative 1. So now we're back at 0. At 5 pi over 4, all right, what's happening here? Now I have a negative square root of 2 over 2 over a negative square root of 2 over 2. Notice I've got a negative on the top and a negative on the bottom. The result of that is just going to be a positive 1. Does that make sense? Let's think about this. First quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. So it makes sense at 5 pi over 4 we would have a positive 1. Once again, let's look at this 3 pi over 2, because that one's going to give us what? We're going to have a negative 1 over 0. Now we've got that another scenario where we are undefined. Alright, so if we take a peek at our unit circle, here at pi over 2 and here at 3 pi over 2, we are undefined. Tangent is therefore undefined at every pi over 2. The caveat to that is as long as we are not shifting. So what is this undefined business? How are we going to graph that? We have to graph it as an asymptote. So let's go ahead and look at doing that. This graph here, chart here I should say, is a little different. I started at negative 3 pi over 2 just to give you a good feel for how it's working. First thing's going to happen is at that point negative 3 pi over 2 is we are going to have an asymptote. So let's go ahead and we'll make asymptotes be nice and pink today. So the asymptote is then happening here at 3 pi over 2. That didn't come out too well. Let's try that again. Let's just make it green. 3 pi over 2, much better. Alright, then if we're looking at here at negative 5 pi over 4, we're going to be at negative 1. At negative pi, we're going to be at 0. So let's go ahead and mark that here, and that's going to be our negative pi. So negative 5 pi over 4, I'm down here somewhere. At negative pi, I'm here. And then at negative 3 pi over 4, we're going to be up here at 1. What is then going to happen here at negative pi over 2? At negative pi over 2, we're going to get another asymptote. Okay, at then negative pi over 4, we're here at negative 1. If we scroll on down, what's going to happen at the origin at 0, we're going to be here at 0. At pi over 4, we're going to be back here at 1. At pi over 2, what's going to happen at pi over 2? Right? We're undefined again, so we need to put in another asymptote. If we go ahead and we sketch these curves up, right, that becomes our result. So that's what a tangent graph looks like. What are you going to have to demonstrate when you graph a tangent for me? You're going to have to show me where these asymptotes are, and you're going to clearly label them. Those are key if we're going to get full credit on anything. Let's go ahead and let's just take a peek at it. And this shows you real nicely the periodicity. And let's talk about the equation for a tangent. All right, so if we have y equals, right, if we have y equals the tangent of theta, and we can go ahead and write it this way. If we have y equals the tangent of bx plus c, and start talking about it in these terms. First off, is there an amplitude? No, there's not going to be an amplitude, because the amplitude technically is infinity, or it doesn't have one. It doesn't have that limit like a sine and a cosine does. All right. Instead, we have these asymptotes here, and let's look at how often these asymptotes happen. The asymptotes basically happen at every pi. So every pi, if we go from pi over 2 to pi, that right there is then going to give me a period. So that's our period for this one. Let's go ahead and then talk also about domain. What's going to be the domain for this one? The domain for this one is basically going to be all real numbers where x does not equal pi over 2, and then we're going to do this way, plus n pi. So that takes into account all of them. What about the range? The range is then going to run from negative infinity to infinity. So this is a little different than this is a little different from what was going on with our sine and our cosine terms. Now, what do we know about tangent? We know that its kissing cousin, so to speak, is the cotangent. All right, and we can then look at the cotangent. What's going to be the difference between the tangent and the cotangent? It's going to be where those asymptotes are going to occur. Notice, for the cotangent, the asymptote is going to happen here at negative pi, 0, pi, and 2 pi. So you would work it exactly the same way to develop the graph. The difference is where those asymptotes are occurring. And that concludes our discussion and development of the tangent graph.